Assalamualaikum and a very good day, class. So we meet again. Now we go to the incremental search. Incremental search is a technique of calculating fx for incremental values of x over the interval where the root lies. It starts here with initial value x naught, and then from that you need to calculate the value of xn for n equal to 1, 2, 3, and so on. So here, how can you calculate your xn? Xn equal to the formula of xn minus 1 plus h. In this case, we start here with the x naught. And then you need to calculate the next one. Of course, for the n equal to 1, means that you need to calculate x1. How to compute this x1? X1 equal to x is n minus 1, which is 1 minus 1 plus h. So here, when this n is 1, it is equal to x naught plus h. From here, you know that you will have, for example, x naught equal to 0. And then x1 means that equal to 0 plus h. And remember, in the question, I will give you this h. H will be given. It is given. So, where this h is referred to as step size. Once we got this all x value, you need to find the function of fx for each x value. So means that based on this, you need to form a table. This is x, this is f of x. For example, here we have x0, and then the next one, let's say 0.1, 0.2, and so on. So once we got these all x, you need to find what are the values of f. By finding the value of f here, you can check where actually the sign of 2fx changes. And if fxn times fxn minus 1 less than 0, means that in this case, if we remember in graphical method, when we plot, one function, for example, is positive, another function is negative. So it is ensured that there is root in between two values here. Means that in this case, when we multiply the first function with the second function, we'll got here value less than 0, then the root exists over the prescribed interval of the lower bound xl and upper bound xu. And then how can we estimate the root? We can use the formula xr equal to xl plus xu divided by 2. So class, we go to this example to make sure we understand well about this. For example 6, we need to find the root of fx equal to 4.15x squared minus 16x plus 8 by using incremental search. Start the procedure here with initial value x naught equal to 0 and step size h equal to 0.1. And you need to perform 3 iterations of the incremental search to achieve the best approximation root. How can we solve this one? So here we start for the first step. The first iteration, we need to start with x naught equal to 0 and h equal to 0.1. Thus, this is the solution for iteration number 1. But how can we solve this one? So, based on first iteration, okay, we start with the first iteration. We will have here from the question the initial value x naught equal to 0 and h equal to 0.1. And our function is fx equal to 4.15x squared minus 16x plus 8. In this case, we need to start with this x naught equal to 0 and h equal to 0.1 as our step size. So based on this, we need to form a table, which is here are the value of x and this one are the value of fx. So our first value must be 0 because x naught is equal to 0. This is x naught. But next, you need to compute the next value, which is x1, x2, x3, x4, and so on. How can we compute x1? Remember, based on the concept, we have formula xn equal to xn minus 1 plus h. If here we want to compute x1, means that n here equal to 1. So x1 equal to x naught plus h is 0.1. But class x naught is given as a first value here is 0. Means that 0 plus 0.1. So you got here equal to 0.1. So x1 value here is 0.1, and then you can compute the next value, which is when you go to x2, means that x2 equal to here will be x1 plus 0.1, which is xn minus 1 plus h. And x1 based on this is 0.1. So 0.1 plus 0.1, you got here 0.1, you got 0.2. Instead, for this one, we have x2 0.2, the next one will be 0.3, 0.4, and so on. Okay, 0.5, 0.6, 0.7, and then class, for each value of x here, you need to compute your f. F is given by this function, means that for the first one, we have here our f when x is 0, so all x here, you need to substitute with 0. Means that you have 4.150 square minus 16 times 0 plus 8. That is equal to 8. So the first one here, you will got 8. When x equal to 0.1, we have function of 0.1, that is 4.15 times 0.1 square minus 16 times 0.1 plus 8. So you can use your calculator to compute this. You will get the answer here, 6.4415. And then class, you can do the same way for the rest. When x equal to 0.2, we have here the answer 4.966. 0.3, we have 3.5735. 0.4, we have 2.264, and then 1.0375. And next, for 0.6 is negative 0.106. And class here, remember the concept of the incremental search. Function of fx will change its sign. So when x 0.5 and x 0.6, we can see here, this one is positive, okay, and this one is negative function. You can see this one, these two values, its function change its sign. When function change its sign, when we plot actually, for example, first one is positive, negative, negative, and then when you plot this one, of course, it will cross x-axis. Means that in between these two x, there is root. Okay, so here, this one, this 0.5, we can denote it as our x lower, and this 0.6, we can denote it as our x upper. Means that class, how to compute root? We have the formula x of root equal to xl plus xu divided by 2. Means that class 0.5 plus 0.6 divided by 2, you will got the answer for the first iteration 0.55 as our root, as the root of the equation. But the question asks you to do for third iteration. Means that this is first iteration. You are not yet complete. You need to go to the second iteration. When we go to the second iteration, you can increase the accuracy of root estimation by making your step size become smaller. For the first iteration, you have h equal to 0.1. When you go to second iteration, you can set h equal to any value, but make sure it is less than 0.01. it is less than 0.1. So class, in this case, I set my next step size as 0.01. And then class understood that XR actually happened in between 0.5 as our X lower and 0.6 as our X upper. So now, how can we choose our initial value here? You need to set your X lower as your X naught. Means that for second iteration, we have X naught equal to 0.5 as our step size. As our initial value. And then class, based on this, we have H, we have our x0, we can compute our x1 for this case, which is x0 plus step size 0.01. So you have 0.51. X2 will be this one, x1, 0.51 plus 0.01. You have equal to 0.52 and so on. Because of this, I have my table all these x values. So for all x values here, I need to compute my function of fx. When I compute a function of fx by substituting this x, each x here in my f, which is f function, we have 4.15x squared minus 16x plus 8. So when x 0.5, substitute 0.5 in this function, then you use your calculator, you got 1.0375 as the solution. And then you can do for the rest, and you can see when our x 0.59, this one positive, but 0.60 is become negative values of x. In this case, we can say that function change its sign, means that this one we can set as our XL and this one as our XU. So that to compute root at this iteration, we can use XR here, XL plus XU, which is 0.59 plus 0.6 divided by 2. And you use your calculator, you will got your root equal to 0.5950. And then class, we can do the same for the next iteration, the third iteration, but now we need to set. Previously, we have h equal to 0.01 from second, this one is from second iteration. But now when we go to the third iteration, we need to make sure our h smaller than this value. So I choose here h equal to 0.001. But my XL based on previous is 0.59. So this XL, we can make it as our X0 for this iteration. Means that the starting value here is 0.59. With this increment 0.001, you can compute the X value. And then for each X, we can compute here our F. And you can see when X 0.59, this one positive, okay? But when x 0.591 is become negative, means that function change its sign here. So we can say we can conclude that this is our XL lower value, this is our upper value. And then from here, you can compute your XR by using formula XL plus XU divided by 2. So this is 0.59 plus 0.591 divided by 2. You'll got this as our solution. And then class, if you want to compute the error, which is epsilon A, the approximate percent relative error, based on chapter 1, we know that epsilon A is given by present value minus previous value divided by present value, which is time 100%. So now class, the present value here means that our XR at this iteration, which is now it is 0.5905, and the previous value, in fact, it is XR at the previous iteration, that is, which is 0.5950. We substitute here and then divide by present value, which is this value, you multiply by 100%, we will got the answer 0.76% error. So that we can conclude for the third iteration, the root of 4.5x squared minus 16x plus 8 is 0.5905. This answer, what we can see here, the incremental search actually is a tedious method because you need to compute for each x, you need to compute the value of fx. And class, based on this, we have the idea. Instead of we use this table, we can actually develop a new method. Mathematician develop a new method that is we call bracketing method. Bracketing method is just based on lower and upper value. You don't have to compute f for each x here, but you need to base on xl and xu only because we know that in between these two values there are root. So how can we do that? We'll go next class for the bracketing method. So for the incremental search, it comes to the end. You will see more interesting topic which is using bracketing method for the next video. Thank you class for your attention.